Okay, Algebra 2, Day 5 notes, definition of sine and cosine functions. It's a little bit of a shortcut for Day 4, actually, once you get the hang of it. Starts off with a little review. Sine is the opposite over hypotenuse, cosine, adjacent over hypotenuse. Some of the things in Day 5 refer to the unit circle, and some do not, so you have to read carefully on each question, make sure you understand what's going on in each one. A few things. Number one, they pretty much give you a unit circle. All right, kind of like what we did on Day 4. The theta is here. Again, later on you're gonna see like alpha, theta, beta. It doesn't matter what letter it is, it's still the angle. All right, they're trying to find the coordinates like you did on Day 4, xy coordinate up here. They want you to find the cosine of theta. Well, cosine of theta, that's adjacent over hypotenuse. So with what they give us is just x over 1. So cosine theta is just x. Same idea for sine though. Sine of theta, that's opposite over hypotenuse, so that's y over 1. That's just y. All right, the xy are just the same as these coordinates, xy up here. All right, tangent, you do the same thing. Tangent of theta is opposite over adjacent, so tangent of theta, well, that's y over x in this picture, opposite over adjacent. All right, whatever those lengths are. Another way to do this, yesterday, Day 4, we tried to find all of those coordinates on the unit circle. All right, and draw a bunch of pictures. There's different ways of doing it. Instead of an xy coordinate, we could actually say this is a cosine sine coordinate. That's what Day 5 is all about. It's a cosine theta, sine theta. Because cosine of theta is x, sine of theta is y. All right. There's some textbook definitions in here. The hypotenuse on the unit circle is 1, right? That's the radius of the circle, so any of these x and y lengths have got to be less than 1, so sine of theta is always between -1 and 1. Cosine, same thing. All right, same thing we just wrote down. Cosine is the x coordinate. So cosine of theta is x, sine of theta is y. Tangent, we said, is y over x. So in this case, it's going to be, you could also say instead of y over x, you could say this is the sine of theta over the cosine of theta. It's the same as tangent. All right, it says it's the most important thing to know. One of them anyway. All right, at the bottom, some decimals that you need to recognize. It's essentially a shortcut. Radical 2 over 2, radical 3 over 2. Put them in the calculator. We'll do that in a minute. Say I give you an example. It's actually on the next page of the notes. If I want to just find the sine of 240. Find the sine of 240 degrees. All right, if you're thinking like we did Day 4, you can do it on the unit circle and draw a picture, I guess. All right, kind of ties the last few days together. 240 degrees is over here in quadrant 3 somewhere, right? This angle is 240 degrees. All right, you label it 240. If it's on the unit circle, let me try to draw a circle in here, close enough. All right, you could drop a perpendicular. They call this the reference triangle, if you've seen those words in there somewhere. All right, there's my perpendicular. 240 is the big angle, but what's the angle or the reference angle inside this triangle we just formed? Well, if this is 180, what's left? So you gotta be 60 right there, right? So that angle is 60. That just forms a 60, 90, this has gotta be 30 down here. All right, so like in Day 4, you have a 30, 60, 90 triangle. You could find all these lengths now. Remember, hypotenuse is 1. Across from the 60, across from the 30, all that stuff. All right, this is 1/2. This is radical 3 over 2. If you're plotting this point on the unit circle, you get to go left and then down, right? So it's actually a negative radical 3 over 2. So the coordinates here are also -1/2, -1/2, negative radical 3 over 2. That's how we did it on Day 4. Day 5, that's too much work, right? It took way too long. You can actually just use your calculator if you wanted to. What is the sine of 240? All right, it's actually the y coordinate. So put it in the calculator. What is the sine of 240? You have to be in degree mode. All right, you get this weird looking decimal. -0.8660, keeps going. All right, that's the same as this one that's on here. right? It's radical 3 over 2. Type that in the calculator, it's the same thing. So 0.8660. All right, all that is the y coordinate for this example. All right, they don't ever want decimals as answers, they want them exact. So for this one, because it's in this quadrant, you have to go down to get it. It's negative radical 3 over 2. All right, radical 2 over 2, put that in the calculator, you're gonna need that later on. That's 0.7071. So if you ever see that, it's radical 2 over 2. 0.8660 is radical 3 over 2, just a little bit of a shortcut, save you some time. Some examples, we just did one of them. Some other ones on the next page. All right, sine of 30, you can put it in a calculator, you can do all the work if you wanted to. All right, make sure you're reading this, these are all on the unit circle. All right, some of you can think a little bit, maybe, I don't know. Calculator do it for you, but sine is the y coordinate at 30 degrees. All right, y coordinate at 30 degrees. If you're thinking of that unit circle, if you have it in your head a little bit, or you're looking at the paper. All right, what's the sine of 30? Should be 1/2. And put it in calculator just to make sure. All right. Sine of 240 we just did. That was negative radical 3 over 2. Cosine of 90. Put it in your calculator, or think cosine is the x coordinate at 90 degrees on that unit circle. All right. What's the x coordinate at 90 degrees? That's should be 0. Cosine of 180. What's the x coordinate at 180? Well, it should be at -1 because it's on the unit circle. All right, keep going. Sine of 90 was the y coordinate at 90. Should be 1. All right, put the rest of those in calculator if you want. Not a big deal. Number 3 in the notes. Terminal ray is alpha instead of theta. Again, not a big deal. Passes through this point, lies on the unit circle. Most important part of that question. What's the value of sine of alpha? All right, it's actually no work necessary for this question. Sine is the y coordinate if it's on the unit circle. All right, so this is just the y coordinate. Well, y coordinate is 0.8. There it is, you're done. All right, all of that just because it's on the unit circle. If it asks for the cosine, it'd be the x coordinate. All right. Number 4 talks about which quadrants have which signs, essentially. The cosine of any angle theta. Think about it. If I'm plotting a point in quadrant 1, all right, up here is quadrant 1. There's a point. All right, some xy coordinate. Remember, that's the same as a cosine and then a sine. Yeah, no real. All right, the x coordinate's positive, the y coordinate's positive. So that means in quadrant 1, the cosine is positive. The sine is positive. Well, tangent, that's y over x, right? Cosine's x, sine is y, tangent is sine over cosine, so y over x. What's a positive divided by positive? That's positive. So in quadrant 1, everything is positive. In quadrant 2, your x coordinates. If I'm in quadrant 2, I'm over here. All right, this is quadrant 2, not 1 like some of you think probably still. In order to graph any point in quadrant 2, I had to go left first, which is negative, and then up, which is positive. So I went negative, and then up, positive. If I'm dividing, positive divided by negative, that's a negative. So the only thing positive in quadrant 2 is the sine function. Same idea, quadrant 3, down here. In order to plot a point in quadrant 3, you gotta go left and then down, right? So I went left, which is negative, down, which is negative. Negative divided by negative is actually positive, though. So tangent is positive in quadrant 3. Quadrant 4, bottom right. All right, in order to plot a point here, you have to go to the right and then down. So going to the right is positive, down is negative. Again, negative divided by positive is negative. The only function positive in quadrant 4 is cosine. All right, there's a bunch of acronyms, abbreviations for that. You see the letters like this sometimes in quadrant 1, A for all. They're all positive in quadrant 1. Quadrant 2, sine is positive here. So you see the S there sometimes. Quadrant 3, what's positive in quadrant 3? It's tangent. So there's why you see the T there sometimes. Quadrant 4, the only one positive is cosine, so C. Use that later on a lot to check your answers. Number 5 and 6, I kind of use this as a chart a little bit. If sine of A is less than 0, so it's negative, cosine is positive because it's greater than 0, which quadrant is terminal side of A lie in? All right. So if sine is negative, well, where's the sign negative? It's only positive here or here because they're all positive here. So if it's negative, it's got to be in 3 and 4. All right, let me want to draw a picture. All right, where's sine negative? In 3 and 4. Where is cosine positive? Well, cosine's positive here and here. Which one fits both conditions? It's got to be in quadrant 4. All right, that's it. 6 is the same idea. Number 7 is a little bit different. All right, read carefully. This one is not on the unit circle. All right, the point 3, -5 lies on any circle. Whose equation is this? All right, remember those circle equations. This is the radius squared. That is not the unit circle. What's the exact value of a cosine angle drawn in standard form? Standard position. All right, terminal rate passes through this point. Draw a picture for all these. All right, there's other ways to do it. For now, draw a picture. The point 3, -5 is in quadrant 4, right? Over 3, down 5. Let's say it's about here. There's a circle going through there. You can draw that in if you want. Doesn't really matter. There's a circle. All right, if I were to draw at the point though, I had to go over and then down. I'm gonna draw a triangle right there. All right, I went over 3, down 5. There's my right triangle I just formed. All right, it says what is the exact value of a cosine? Anytime it wants the angle, it always wants the angle nearest the origin. Like your reference angles there in the last couple of days, it's looking for this angle right here. All right, cosine of that angle, cosine of theta. Cosine is adjacent over hypotenuse though. So adjacent is 3. Hypotenuse, somebody's saying, yeah, we don't know it. You could do Pythagorean theorem. 3 squared plus -5 squared equals c squared. But you know that's on this circle. Right here is the radius squared, so what's the radius? Gotta be radical 34. If you didn't know that, should have paid attention in September probably. All right, so that's square root of 34. Check it out, make sure it works, hopefully it does. Cosine, adjacent over hypotenuse. All right, make sure we get the right answer. You're technically not supposed to leave radicals in the denominator. You can multiply that by radical 34 over radical 34. Gives you 3 radical 34 over 34. Again, it wants exact. It doesn't want any decimals, so try not to simplify with decimals. The last thing, all right, a lot of you do that work, you cruise through it. Make sure you check your answer. All right, this one's going to work out. Cosine in the 4th quadrant is positive, right? Always go back to your chart. Check it. Which one's positive where? Cosine is positive there, so you're good. Keep your answer. Sometimes they will give you one in a different quadrant. You have to check your sign. If it's actually negative in that quadrant, throw a negative sign on there. All right, number 8, 9, more of the same. Check those out, same idea. Draw pictures for each one.